Hello grade 12s. Today I'm looking at the second 2-point perspective paper from the pack. This is the 2015 trials paper. It says Dean Woodley from Kersney. For the 2-point perspectives, I did the first drawing of the 2-point perspective and did step by step the whole drawing, and it made a very long video, 41 minutes, which I think is a little bit long for you to go through and follow all the steps. If you are struggling, yes, sure, then there's a good option to follow. So I'm going to try and condense that a little bit this time and not do all of that necessary information. I'm going to look at the more difficult parts for the drawing and rather focus on those aspects. If I look at this drawing, what do I feel is more difficult or challenging? There is a slope to this roof, which is a little bit difficult. You've got this bar counter on the inside here with a little quarter circle on that. And to me, that's possibly be about the only aspects that I would find particularly challenging for this drawing. So I'm going to draw this base and then go on to the roof and do the roof aspect. The base I'm going to draw straight away and carry from there. The basics that are very important is to line up your piece of paper so that it lines up with your horizontal and your vertical lines are correct. Now we have to do the vanishing points. Now the vanishing points are worth 2 points, and part of it is also in the show the projection mark here. So what do we need to look at? We need to see that the angle that the object makes with the picture plane. On this side it will be a 30 degree, on this side it is 60 degrees. So that means that from my stationary point, and not this intersection, and that's wherever the stationary point might be, I'm going to take a line at 30 degrees and project that up to the picture plane. That's where it's hitting the picture plane. Where it hits the picture plane, I then draw that down, and I'm labeling that my right vanishing point. On the left hand side, also from my stationary point, project my line to hit the picture plane. Where it hits the picture plane, project that back down, and where that intersects here, I'm labeling my left vanishing point. Where the vertical line comes down from this point that's touching the picture plane is my center line, and that is where I would project all my height dimensions to, and that's going to give me the start point of my corners that I'm projecting to the vanishing point. So there's the basic finding the vanishing points. I'm now going to go ahead and draw the base, this base of this little bar area, which is just a rectangle. So the next time you'll look at this drawing, I will have already drawn that. I don't think it's very difficult, and I expect you should be able to do that. There I have the base shape, a rectangle that is touching the picture plane. Very easy to do. Now what I want to do is find the roof. Now with anything that is sloping and then isn't touching the window, remember I referred to the window as the part that would have the edges touching the picture plane. We've got a problem to try and work out that. Now the easiest method I think that we can use here is we're going to create a false center, and we're going to take the lines across this way. I want to take them that way. Why? Because what I can do is I can find this left corner and the right corner of the roof along this same height level, and I'll do the same thing for the top height. So take the top height across to the picture plane, create a false center, and that way I'll be able to then find those 2 points. Here what I've done is projected my line parallel and extended it to hit the picture plane. From that point I projected it down, and I've labeled it my false center. Remember, this is lining up with the front edge of my roof, so I'll now take the front edge of my roof and I'll take that height across to touch that point. Where it touches this point now, I'm going to project it across to my right vanishing point. So somewhere on this line I'm going to find the 2 edges of my roof. To find these corners, we can use the normal method of taking the lines down to the stationary point. Where they hit the picture plane, I then project them down vertically to hit a specific point. And there I have my 2 corners of that roof. If you want to check the accuracy of your drawing, I'm measuring this and the line looks to be about 45 millimeters long. To find my second false center, I'm extending my line parallel to hit the picture plane and draw that line down vertically. Where it hits the extension here of my roof, that's where I'm going to project that across to my right vanishing point. Now, my right vanishing point isn't in your screen at the moment, but there is the line for the back of the roof. Now, to find the specific points, I'm going to take the specific corner, project that to the stationary point. Where it hits the picture plane, I draw the line down vertically. Here's one edge, here's the second edge, and there I have the roof. There is the highest point of the roof. That's looking a little bit smaller. That says about 38 millimeters. And I now join up the front edge to the back edge. And there I have the construction of my sloping roof. Let's start looking at the bar counter. Now the bar counter is floating in the middle of this little area. So we need to find where those points are. The 2 methods that we can use, the one is the false center method, when we're going to create a false center to find where these points are going to be. The second method I refer to as where we have to take it to the window. So remember, this edge here is my window. as would this edge be my window. Why? Because those points are touching the picture plane. So if I wanted to find this corner, what I can do is the following. I can take this line and project it to that window. Now I find where that window is on my drawing. Now I've already got that base shape. So what I do is I take that line to my stationary point. Where it hits the picture plane, I project that line down, and that gives me this edge. Sorry, let me zoom out a sec. So it's found this edge on my window, but that's not where this point is. So what I still need to do is take this line back to my vanishing point, which will give me this line running back of the shape. And now take the specific point. So there's the specific corner. Project that line down to my stationary point. Where it hits the picture point plane, take that line down, and there that gives me that edge. So I've now got this one edge here. To find the second edge here, I'm going to use the false center method just to show you the different method we can use. So remember the false center method, we project and extend the edge that we want. That then drops a vertical line down. Now I take the height and project the height measurement to my false center, giving me this point, and I then take that back to my vanishing point, and now I can project the edge down. There's the edge. Project that down to hit my picture plane. Where it hits my picture plane, I'll take that edge down. So for this arc I've got here, I've already got one point and my second point. And I now need to get some more points to find that arc. So what do I want to do there? I want to use the same method that I do with most circles and put in some pizza slices. And I now need to find these points. Recapping my methods here, I've got take it to the window. I took the line, extended it to the window, took the window point to the stationary point where it hit the picture plane. I projected the line down to hit and give me the point on the window. From the window I extend back to my vanishing point. Then I need to find the specific point by taking the specific point to the stationary point. Where it hits the picture plane, I project down and I find the point. My second method was the false center method. So your point you extend to the picture plane. We then project that down vertically. We take the height measurement to that point and then we extend it back to our vanishing point. Then to find the specific point, as usual, project your stationary point. Where it hits the picture plane, project the line down. You now need to choose which method you are most comfortable with and follow that method to find these points. I'm going to choose the take it to the window method to find these 2 points. So the process that I need to follow is to project the points to the window, project them to my vanishing point, to my stationary point, I've got those 2 points there now, on top of each other almost. There's my 1 point where it hits the window. My 2nd point where it hits the window. Take them to the vanishing point. Now I need to find the specific point. So take the specific point to the stationary point. Where it hits the picture plane, we'll take them down vertically. So those are the 2 specific points. I need to project this down. There, it's hitting that 1 point there. Here's my 2nd point. Project it down. Sorry, I've taken that to the wrong line. And there are my 4 points. I've zoomed in now, and here is where I'd have to join those 4 points as the curve of the bar. To find the height of the bar, I'm now going to use my false center method. So here is the line that I'm using as the false center for this corner here. I'm going to project the height of my bar across to touch that false center, and we then have to take that line up to our vanishing point. That point now gives me the height of the bar. Now, instead of trying to find each of these heights again, what I'm going to do is project the lines up from their points, I would then take a paper trammel. What does that mean? And I'm going to take a blank piece of paper. I'm going to mark off the height for this point. And now take it to each of the other points. So there I've moved it across. Move it across to my next line. And my last line. And that now gives me the highest point of the bar counter. So that is what I feel is the difficult aspect to that. The remainder of this, finding the other edges of the bar, shouldn't be too difficult, and finding the walls that are attached on the side and the back wall.